Okay. Can I get somebody to volunteer to read that for me? Somebody willing to read that? Anybody? In the 2005 conference, USA basketball tournament, Memphis trailed Louisville by 2 points. At the buzzer, Memphis's Darius Washington attempted a three-pointer. He missed, but he was fouled, and he went to the line for 3 free throws. Each made free throw is worth 1 point. What I want to know, and what we're going to determine today, was it smart that the other team fouled him? Was it smart for them to foul him? So I want to watch the setup real quick for this. All right, so they're going to do the replay of this three-point shot foul. All right. So what I want to do first, I want to figure out now all possible ways that the shots could fall for these free throws. So there's like, they give one example, he makes the first shot and then he misses the next two. What are all of the possibilities for the way these shots could fall? We could make all of them, so we're going to call that make. What else could happen? Miss make. What else could happen as he steps up? Miss make. Miss. Or make, miss make, miss make, miss. Are there any other options? Make, miss make. Miss make, miss. Make, miss. I feel like we're missing one more option. Make, miss, the one that they gave us, but let's go ahead and write it down here so we got them all. Make, miss. Is there anything else that could happen? He makes them all, he misses them all. He makes one shot. He makes two shots. How many different options did we come up with? How many different ways of doing it? 8. 1, 2, 3, 4, 5, 6, 7, 8. Darius back in 2005 was a 72% free throw shooter. I want to find the probability that Memphis will win, lose, or go to overtime. So we're going to find these probabilities here. So, oh, where'd my stuff go? How did that all just pop off of there? There we go. Weird. Which of these options has Memphis winning the game? Just option number 1. All right, so if it's a make, it's a win. So 3 makes. How does Memphis lose the game? Miss. So miss, so 3 misses. Or if he gets, what, 2 misses and 1 make? And there's different ways of that happening. But 1 make, 2 misses, and they lose. And once I pop this up on the screen a little higher, we'll write down all the ways that that can happen. How do they go into overtime? What would have them going into overtime? Miss, we said has them losing. Yeah, two makes and a miss. However, those happen to be organized, because that would tie the game. All right, I'm going to pop this up a little bit higher on the screen so that we can figure out how to calculate this, and I have more room to write all that down. Oh, come on. To try to make some of this fit in here. Good grief. All right, I got all those to fit now. All right. Let's try to calculate some probabilities here. We said that Darius was a 72% free throw shooter. What's the probability that they win the game? That's okay. Let's talk about it. What's the chance that he makes the shot? He steps up to the free throw line. What's the chance that he makes it? 72% right here. So just talking about the first make. So 0.72, that's his first shot. Does whether or not he makes the first shot affect if he really is a 72% free throw shooter? Is that going to affect his chances on the next one? No. So what's the chance that he makes the second shot? 72%. So I'm going to multiply that by 72. These would be independent events, so I can multiply these together. What's the chance he makes the third shot? Yep, 72%, 0.72. But if I multiply all those together, I get what? 0.373. So what does that mean? Absolutely. So Gracie, you weren't that far off. About a 37% chance that they're going to win the game since the other team fouled them. Probability that they lose. We said miss has them losing. How do I find out the probability that that he missed all three shots? Yes. So I'm going to do 1 minus 0.72 or 100% minus 72%. What would that give us? 0.28. This is probability of a miss. So how would I find the probability that he misses all three shots? Yep, absolutely correct. We're going to do 0.28 times itself 3 times for each shot. What would that give me? Yep. 0.022. So the chance that he misses all 3 shots when he steps up to the free throw line, about 2%. But there's another way that they could lose this game. He doesn't have to miss all 3 shots for them to still lose. What else could happen? Yeah, he makes 1 and misses 2. How many ways did we have of that happening? Where he makes 1 and misses 2. 3 different ways. We had make, miss, miss. We had miss, make, miss. And miss, miss, make. So there are 3 different ways that this could happen. So this would be times 3. So what's the probability that he makes the shot? 0.72. What's the probability that he misses a shot then? 0.28. Probability that he misses another shot? 0.28. When I'm multiplying things together, does the order matter? No. But we know that there are 3 orders that this could happen in, so I still need to take that and multiply it by 3 because there's 3 different ways he could make 1 and miss 2. So what's the probability that he makes 1 shot and misses 2 shots? 0.056, but then don't forget to multiply it by 3. Yes. Times 3. So we get 0.169 here. All right, and now let's look at going into overtime. They go into overtime if he does what? Makes 2 shots and misses 1 shot, right? So probability that he makes a shot, 0.72. Probability that he makes another shot, 0.72 again. Probability that he misses a shot, 0.28. How many different ways did we list out that he could make 2 shots and miss 1 shot? 3. So I have to take this right here times 3 different ways this could happen. So I want you just to multiply those together, and then we'll multiply it by the 3. So what is it if I just multiply 0.72, 0.72, 0.28? 0.145. Now I need to take that, because that's the probability of just 1 way of 2 makes and a miss, but we have 3 ways of that happening. And so what would that be? 0.435. All right. This right here, when I'm seeing that there's multiple ways for this to happen, I have a couple different ways that I can represent that, but I want to show you guys one way that we can represent that idea instead of having to write down times 3 ways. Because the only way I knew this is because I wrote these all out here. All right. So we had 3 times 0.72 squared, I'm looking right here, times 0.28. This idea right here is a combination where I don't care about the order, but there's 3 shots and he makes 2 of them. 0.72 squared, 0.28. I'm going to show you how to put this into your calculator, but this is called a combination. This is a combination. We found that there were 3 combinations where he makes 2 of the shots and misses 1. Let me pop this down just a little bit if it will let me. Nope, it's not going to let me right here. Okay, so down at the bottom, I apologize because I'm practically going to have to kneel for this. So N, C, K. N would be my total shots. Since he got 3 free throws, I would put the 3 there. This right here would be the number of makes. And then we take that and we multiply it by P to the power of K. This K here is still number of makes. P is the probability that we make a shot. probability of a make. And then we also need to multiply that to 1 minus p to the power of n minus k. 1 minus p is the probability of failing or miss. And n minus k would be the number of misses. All right. I'll write that down again later, I promise. A little bit higher up on the screen, but I want you guys to go ahead and pay attention to that particular piece. I'll show you on your calculator how we can access that C for combination. But this is so I don't have to list out every possible way of doing it, because the more free throws somebody would get, the more different combinations of ways things could happen here. Does that make sense? By being able to do this combination right here, I can say how many total are there and how many do I want him to make? And it'll tell me how many ways that can happen. All right. So I want to look at these probabilities, the ones that I have circled in black here. We're going to write those down in the table for number 3 across that top column. So the probability that it is a win is 3.73. Or sorry, 0.73. 0.373. What's the probability that Memphis loses? So what were the numbers that we had circled in that center one there? Yes, 0.022 and 0.169. Remember, that was 3 misses, and that's 2 misses and 1 make. So what do I get when I add those together? .191. And the probability that we go into overtime is what? .435. All right. I'm going to pause this here in our calculations, and we're going to watch his first shot. Right now, as he steps up to the line, there's a 30% chance or 37% chance that they out and out win. 20% chance, not quite, 19% chance that they lose the game, and almost a 44% chance that they head into overtime. All right, he steps up to the line. All right, so he made his first shot. So what's the score right now? 74. What has to happen now for Memphis to win? 2 makes. So let's look at what their chances are of winning now. He needs a make and a make yet. How do I find that probability? 0.72 plus 0.72 times So 0.72 times 0.72. The chance that they win the game is now what? 0.5184. You guys like those odds? What's the chance that they lose the game now? Like, how would that happen? I'm sorry, one more time. He misses both of the next shots, right? Because this was miss, 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 or make, miss, miss. So if he misses the next two shots, they lose. What's the probability that he misses a shot? 0.28. So what's the probability at this point right now that they lose? 0.0789. What are we thinking about our chances? Thank you, sir. How do they go into overtime? Make, miss, or miss, make? Oh, I wanted to write that in green. So make, miss, or miss, make. So we've got two different options. What's the chance that he makes a shot? 0.72. The chance that he misses? 0.28. And how many ways could he make one and miss one? 2 ways. Because there are 2 options here. So what's the chance that they get sent into overtime? 0.4032. 50% chance they win, 40% chance that they go into overtime, something close to an 8% chance that they lose. You ready to watch his next shot? All right. Watch it again. He did not make that shot. So score is currently what? 74. Can they win the game? No, he can't win. At best, he can do what? He can hope for overtime, taking it to a tie and going to overtime. How do they lose the game? With a miss. What's the probability of a miss? 0.28. How do they send it into overtime? If he makes it, 72%, 0.72. You ready? Nope. He missed it. Huh? Right? I feel really bad for him. He is. Poor guy. So literally when you look this up on YouTube, it is called, yes, this is the Darius Washington game. Oh, poor guy. Hmm. All right. Washington is a 40% three-point shooter. Do you think Louisville was smart to foul him? Do you think that was a good choice for Louisville? Was it smart for them to foul him? Let's look. All right, so I'm hearing lots of yeses, so I'm going to write it off to the side with a question mark yes next to it. So remember, it was Louisville that fouled him at the buzzer with his three-point shot. If Louisville didn't foul him, what was the chance that Memphis won? 40%. If Louisville does foul him. What were the potential options there? Win or tie. What was the probability when he stepped up to the line that he was going to win it outright on those foul shots? 37.3%. So Memphis has a 37.3% chance of a win. Or you said he can send it into overtime. What was the probability that they were going to send it into overtime? 43.5% chance. Does that seem like a good risk to take by fouling them? Kind of depends, right? I guess it would depend on the rest of the team. But I'm going to go more with the question mark here and less with the yes. Because I don't think there's a clear answer here. 37% chance that they win versus a 40% chance. Okay, that looks good, except you're also throwing in this wild card. And I feel like that's where, especially if they've got some high scorers on the other side, or on Memphis's side, you'd have to look at the team as a whole. But this was such a close game at the end, it might not have been a great decision to foul them. All right, go ahead and flip your pages over. Big ideas here. Yes. As far as the combinations and walking through all the steps. I can't say yes or no just because they change the questions up every year, but what I can say is if you provide some justification for your answer, if it's an open-ended question where there's not a clear yes or a clear no, support your answer. All right, so what we looked at here when we were talking about number of trials and number of successes. This is binomial. Binomial means that each trial is either a success or a failure, which we can look at with the basketball. He makes those shots, or he takes the shots and he either makes them or misses them. Each trial has to be independent in order for me to be able to use this formula. So the results of the first trial cannot impact the results of the second one at all. The number of trials has to be fixed. In this case, we knew he was going to take exactly 3 free throw shots. And the probability of success for each trial has to be the same, which kind of goes along with our independent here. So we use the acronym BINS to help remember whether something is binomial or not. Is it binary? Is it a yes, no? Are there only 2 possible outcomes? Are they independent? Do we have a fixed number of trials? Do we have the same probability of success for each trial? Binomial formula. I promised I'd put it up a little bit higher on the screen and written out clearer. So I'll come right back to this screen, but I do want to show you on your calculators how you access the combination button right here. You have to start off on your calculators. My emulator up here is a little bit different, but I can still show you where the button is. You have to put in the total number of trials first into your calculator. So I want you guys to practice as if we're talking about the free throw question. So go ahead and pull out your calculators. How many free throws did he get? 3 free throws. So go ahead and pop a 3 in there. So after you type the 3 in, do you guys see the button that says math? Button that says math should be right underneath the alpha key, the green key. Go ahead and hit that math button. Do you see where it says PROB for probability? Arrow over to PROB. You see the one that says NCR? You want that option. So choose NCR, and then you put the number of makes that you want. Those of you that don't have a TI calculator, I will try to help you find the option on yours in just a moment. So first you enter the number of trials, then you go choose this button, and then you put in your value for K afterwards. How many successes you want. How many successes did we want here? 3. So go ahead and pop a 3 in. We wanted 3 so that he could win. Hit enter. There's one way of doing that, right? What about if you do it 3 free throws and we want 2 successes? 2 shots to go in. Yeah. Very, very helpful if there's more trials. Please make sure that you get the rest of this copied down. We're going to do the check your understanding at the very beginning of class tomorrow. Let me try to help you find it on yours. All right. A lot of times on these. No. SEO power graphic tree. Let me look it up. There'll be a whole probability menu, but let me look that up. Power graphic 3. You have a power graphic 3 also? Okay. I'm going to look up how to find your probabilities on there, and I will let you guys know tomorrow. You know what? I want to make sure that I look up the right model number. So let me snap a quick picture of that. Yes, sir. So first you need to find the new mean and the new standard deviation by combining those random variables.
Why are we combining these?
The probability that Mr. Voss's score was higher than Mr. Cole's.
Right.
So what you can do is subtract those. Because if Mr. Voss is higher than Mr. Cole, then it's going to be a positive number.
Normally distributed like difference between them.
Yes, that's exactly right. Yes. All right. Have a fantastic rest of your day, guys. We'll start off with a check your understanding tomorrow, first thing.